Agentic AI is everywhere right now. But is it really new or just a fancier way of saying autonomous AI? In this video, we'll cut through the noise. I'll show you what truly makes Agentic AI different, how it perceives, plans, acts, and learns, and why it's suddenly showing up in tools, workflows, and real products. Whether you're into coding, automation, or building with LLMs, this will give you a clear picture of where things are heading in the AI space. Let's get started. In my last video, we explored how autonomous AI systems could take actions without constant prompts, unlike your typical assistant or chatbot that just waits for input. But Agentic AI takes the autonomy even further. It's not just reacting, it's perceiving, reasoning, acting, and learning, like it's running with a game plan. And here is why this matters now. With tools like Devin, AutoGPT, LangChain, and OpenAI's new Agent SDK, we are seeing agents that can write code, solve tickets, search the web, and collaborate, all with minimal human input. What used to be a research toy is now starting to ship in real products. So, what exactly is Agentic AI? Think of it as an AI that doesn't just wait for commands. It understands the goal, figures out the steps, uses the right tools, and adapts as it goes. Behind the scenes, most agentic systems follow a 4-step loop: perceive, reason, act, and learn. First, perception. The agent gathers data. That could be form of APIs, databases, user chats, sensors, or web searches. It's like the AI is looking around and picking up signals. Next comes reasoning. Powered by LLMs like GPT-4, the agent breaks down the task, plans what to do, and decides which tools or APIs to use. Sometimes it even taps into external knowledge using techniques like RAG, Retrieval Augmented Generation, to get real-time data. Then it's action. It actually executes the steps, making API calls, writes code, sends emails, even runs shell commands, and if something fails, it can self-correct. Finally, learning. Based on how well things went, the agent stores that experience. Over time, it gets better at handling similar situations. Let me show you how this works under the hood. At the center, you have got your AI agent, powered by an LLM. That's the brain doing the heavy reasoning. It connects to databases to gather context. That's perception. Then, it plans and takes action, like calling APIs or executing tasks. What's powerful here is the data feedback loop. Every action and outcome gets stored, improving the agent over time. And that's how it learns, continuously refining itself. And all of this stays grounded in the environment we defined, the tools, systems, and data it's allowed to use. The agent isn't running wild, it's goal-driven with human-defined boundaries. Let's take a real-world example. Say you're deploying a code update. A traditional AI assistant might help you write the deployment script. But a code deployment agent, it will go way further. It can detect the new code push, pull the repo, run tests, check for breaking changes, choose the right deployment pipeline, push it live, and notify your team on Slack, all without needing your input every step of the way. And if something breaks, it can roll back, look into logs, or even raise a ticket, depending on how it's configured. And that's the key difference. Traditional AI and assistants are reactive. They wait for you to tell them what to do, one prompt at a time. Agentic AI is proactive. It takes the goal and runs with it. It doesn't just assist, it acts, adapts, and learns. So, how do you actually build one of these AI agents? At the core, you'll need 4 main pieces. First, an LLM. This is your agent's brain. It does all the reasoning, breaking down tasks, planning actions, and figuring out what to do next. You could use GPT-4, Cloud, Mistral, or any capable foundation model. And then you have a memory layer. Unlike a regular chatbot that forgets the last thing you said, agents need memory. This helps them stay on track, remember past steps, and learn from outcomes. You can use short-term memory like conversation history or long-term memory with vector databases like Pinecone, VV8, or FAISS to recall previous results or decisions. And then you have tools or APIs, which allow your agent to do stuff in the real world. Tools could be a calculator, a database query, a code executor, or even a shell access. For example, if your agent is fixing bugs, it might run tests, submit pull requests, or even check CI/CD pipelines, all via APIs or command line tools. And then we have an orchestration framework to glue it all together. You give the agent a goal, like ship this feature, and the framework breaks that into steps, manages memory, routes decision, and connects the LLM to tools. It basically defines the workflow. And some popular choices are LangChain, which is great for chaining steps and building modular agents. OpenAI's Agent SDK is fast-moving and tightly integrated with OpenAI tools. Crew AI lets you create teams of agents with defined roles. And AutoGen by Microsoft helps agents collaborate via structured chat flows. Let's say you want an AI agent that can deploy code safely. So you first pick an LLM, say GPT-4, to understand instructions and plan deployment steps. For memory, you can choose Redis or Pinecone to track which services were deployed, past failures, etc. And then you can choose tools like GitHub API, say to pull code or create PRs, CI/CD APIs like Circle CI, GitHub Actions, and shell commands. And for the framework, you can think about LangChain or OpenAI's Agent SDK to orchestrate the workflow and handle retries if something breaks. You could say ship version 1.2 to staging, and the agent handles everything, pulling the repo, checking configs, kicking off deployment, and logging results. Alright, now let's zoom out a bit. All of this orchestration, the back and forth between agents, tools, and goals, needs some kind of structure. And that's where MCP comes in. If you saw my previous video on MCP, the Model Context Protocol, you know it's a game changer. In agentic systems, where multiple tools, APIs, and even agents need to collaborate, MCP defines how that coordination happens. It gives structure to conversations, tool calls, memory access, everything. And so, instead of chaotic prompts flying back and forth, you get a clean, modular protocol that LLMs can follow to stay on task. It's like a smart middle layer, making sure each component in your system, whether it's a tool or another agent, understands the full context of what's happening. And that's critical when agents are solving multi-step problems and need to reason across tools, memory, and environments. So, if you're planning to build scalable agents or deploy them in real workflows, MCP is not just nice to have. It's essential. Agentic AI isn't just the next hype cycle. It's a shift in how we think about automation, reasoning, and what AI can actually do for us. Whether it's writing code, solving tickets, or driving real-world actions, we are now building systems that not only understand goals, but pursue them. If you are a software engineer, now is the time to explore the space. Start small, pick a task, wire up, and see what it can do. Because the future of AI isn't just conversational, it's agentic. And if you found this video helpful, I have got more coming, from hands-on agent builds to real-world system breakdowns. Hit subscribe and check out my earlier video on MCP to go deeper.